Today I discuss some problems related to complex number system. So what is modulus and antecedent of complex number? I am described this in previous example. Now I just discuss some problem. Here you can look this is the real axis and this is the real axis, imaginary axis, and this is the complex number. So here any complex number can be represented in complex pair. So any complex number in the number in this form x plus iota y can be represented in this complex pair. X is the abscissa and y is the ordinate. So here r is the distance from the origin to the complex point where the complex number lies, and r is the modulus of the complex number, which is represented by root over x square plus y square, since this is a right triangle. And amplitude of z is the theta angle, which makes the line OZ with x axis. So this is theta is equal to tan inverse y by x. Now, what is the modulus negligent form? This is z is equal to r cos theta plus I r sin theta, or r for r into cos theta plus iota sin theta. This is the modulus negligent form. Now I'm going. I have also tested this that argument of multiplication of two complex numbers must be equal to argument of z1 plus argument of z2. So I have taken complex numbers into complex numbers and found the multiplication of z1 z2, it comes z6. Then I have deduced that what is the argument of this? This is 5 by 6, and here just I have found out the argument of z1, this is 5 by 3, and argument of z2. So here it is a problem that the point lies in the fourth quadrant. So we have to take clockwise direction, this will be minus theta. That's why the minus sign will come here. So minus tan inverse 1 by root 3, this is minus 5 by 6. Now when we add up these two, then we get the same 5 by 6. So here 5 by 6. So this relation is true. I have tested. You can take test through taking z1 in another complex number and z2 in another complex number. You can verify this relation is true in the complex number. Now a problem is given that if alpha is 1 plus iota by root 2, then show that alpha to the power 6 plus alpha to the power 4 plus alpha square plus 1 is equal to 3. So here given that relation that alpha is equal to 1 plus iota root 2. Cross multiplication to alpha is 1 plus iota. And square in both sides we have 2 alpha square plus 1 plus iota square. So here we will get a plus b whole square formula, 1 plus 2 iota plus iota square. Iota square is equal to minus 1. So here we will put minus 1, then 1 side take 0, and we will get 2 iota. So alpha square is equal to iota. Now we put the value of alpha square in this expression, and alpha is can be written down alpha square is equal to alpha 4 can be written down alpha square whole square, alpha square whole square, and alpha square plus 1. So there is iota whole cube, alpha square value iota, iota whole cube, iota square, iota and plus 1. So iota cube what will be? Iota cube can be written down iota square iota. So iota square value in minus 1, this will be minus iota. So here this is minus iota, iota square is minus 1, here iota and 1. Then subtracted this, you will have 0. So this is you have to prove that this expression is equal to 0. Now let's do another problem. Given that if z is equal to lambda plus 3 plus iota to the power 5 minus lambda square, then find the locus of the z in the complex square. So lambda is a parameter. Lambda is a parameter. So we have to find out the uh, locus or the equation of z in the complex square in such a way that lambda can be removed. We have to remove lambda from this equation. So for this we will take z is equal to represented by x plus iota 1. Then this is equal to this. We know that in a equation real part always equal to real part, imaginary part always equal to imaginary part. So equating this we have x is equal to lambda plus 3. Then we have x minus 3 is equal to lambda and x minus 3 is equal to lambda square. And y equal to power 5 minus lambda square. So what is y square? Y square is 5 minus lambda square. So here if you put lambda square value, what is this? X minus 3 whole square. So this is 5 minus x minus 3 whole square. Now if we erase this will be x minus 3 whole square plus y square power equal to 5. So this is the equation of the circle. This is the equation of a circle. So this is the locus of the point J in the complex square. I hope you like this map. Now go to another problem. Get the another problem. So that the points 3 plus 2 iota, 6 plus 4 iota, and 9 plus 6 iota in the argument plan are collinear. Collinear means like in the same line. 3 points must lie in the same line. They cannot one point lies here, one point lies here, and another point lies here. It cannot. 3 points lie in a single line. So we have taken this complex number z1, this is z2, and this is z3. Now look this z1, z2, z3. I have write down here in this way. But actually, these complex numbers lie in the same line. Later, first we have taken arbitrarily z1, z2, z3 lies in this way. Now, what is AB? If you take this a position vector, so AB OA is the position vector of Z1, OB is the position vector of Z2, and OC is the position vector of Z3. So AB must be OB minus OA vector. So this will be Z2 minus Z1. So we will have this complex number. So what will be the modulus of this complex number? 30. And in this way, we find out BC. This will be equal to OC minus OB. So this will be Z3 minus Z2, and subtracting those, we will have 3 plus 2 iota. So modulus of this BC complex number is 13. Now we find out what is the AC. AC can be found out by subtracting OC minus OE. So Z3 minus Z1, this will be 6 plus 4 iota. So modulus of this vector, AC vector, AC complex number is 2 plus root 3. So you can find out that if the three lines does not lie in a single line, then if then there must be a triangle. If 3 points generates a triangle, then they cannot be collinear. And if there are 3 points uh, um, uh, makes the triangle such a way that the area is 0, then this is collinear. So here we will prove that the 3 points J, A, B, and C. If you look this, The head of AB plus BC is equal to AC. So the longer side is equal to the smaller two sides. So it cannot form a triangle. It must be a collinear. So here Z1, Z2, Z3 are collinear or lie in the same line. Now there is another problem. If modulus of 2z plus 1 is equal to modulus of z minus 2 iota, then we have to show that 3 into x square plus y square plus 4 into x plus y is equal to 3. Where z is equal to x plus iota 1. So here, if we put z equal to x plus iota 1 in this equation, what we will find out? Find out 2x plus 1 the real part and iota 2y is the imaginary part. Here we will find out x is the real part, y minus 2 is the imaginary part. Then we will square both the modulus. Then we have 2x plus 1 whole square, the real part whole square plus the imaginary part whole square. Here also the real part whole square plus imaginary part whole square. So we have, if we will now use the formula of e plus b whole square a minus b whole square, we have this expression. Now if we rearrange this, then we will get simply the real which is asked in this question. Now another one, and look all these problems are important for higher engineering students. So must study these problems, repeatedly watch and higher engineering students. So repeatedly watch these problems and try to find out another ways to solve this problem. Here we are given e power of minus 1 plus e power minus 1 plus e power minus 1 up to infinity is equal to minus omega or minus omega square. So this will have to show that. So we have taken that if z is another number which is equal to this expression. Now we will take z square. So this will be 1 square will remove. Then we will get minus 1 plus e power minus 1 plus e power minus 1 plus e power minus 1 plus up to infinity. So again this expression comes, this is equal to z, we will put here z. Then we will get a quadratic equation of z which have two roots. So we will find out the roots. Z is equal to minus b plus minus root of b square minus 4ac by 2a. We will put the data and find out the roots 1 plus minus root over minus root 3 by 2, which will be 1 plus minus I root 3 by 2. So you can remember also here that the cubic roots of 1 is 1 minus 1 plus I root 3 by 2 and minus 1 minus iota root 3 by 2. So if you take any one omega, then other might be omega square. So here the forms of the roots are similar to this. You have to take negative for both the roots, then you will get this is equal to the cubic root of 1. Immediately cubic root of 1 both the roots. So we'll take my negative of, we'll find out that this is negative of omega square and negative omega. So we have proved this, that this expression is equal to either minus omega or minus omega square. No, two more problems. Let's see this. Important one. Here again a relation is given that modulus of z square minus 1 is equal to modulus of z whole square plus 1. Where z is a complex number, we have to again find out the inverse of the z in the complex number. So z is equal to x plus iota y. So z square must be equal to x square. Iota square is minus 1. So this will be y minus y square plus iota 2x1. Now we will put here, so this rearrange in real part and imaginary part. So give the real part x square minus y square minus 1 and imaginary part I iota 2x1. So and the right hand side, just modulus of z square is modulus of z is root over x square plus y square and whole square gives us x square plus y square plus 1. Now, here left hand side, there is also modular. So here real part is this, and this is the imaginary part. So modulus will be into our real part whole square plus imaginary part whole square, and the right hand side is same. Then we will square on the both sides, both sides. Then this form will make, and then we will use a plus b plus c whole square formula. This will be a square plus b square plus c square plus 2b plus 2c plus 2ca, and here also a square a plus b plus c whole square formula, and then just calculate 4x square minus 4x square equal to 0, it will be x equal to 0. I mean x equal to 0 is the it is the equation of y-axis. Equation of y-axis. Equation of y-axis. So very easy. That the locus of the z, the complex part is the y-axis. Now, here if you have not subscribed this channel, then subscribe this channel to continue getting videos. Subscribe this channel and share with your friends. Like and keep watching my videos. And last problem that Z1, Z2 are two complex numbers, and the Z1 not equal to Z2, but modulus of both of them are equal. So that the real part of this expression Z1 plus Z2 by Z1 minus Z2 is 0. So we have taken we have multiplied both the expression with the conjugate Z1 conjugate of Z1 minus conjugate of Z2. So we will find out that in one place this relation comes with negative with positive sign and with negative sign. So if you take positive negative both the sign together, positive negative, then when it is positive you will get, when it is positive you will get real part, real number, and when you will take negative, when you will take negative sign, then you will get purely imaginary part. Iota, there will be 2 iota x y1 minus x1 y2. So you can find now there is negative, it will be purely imaginary, and these are equal given mass finishes, and then the denominator part, this is purely real, this is purely real, and this part is also a real number. Denominator is purely real, and the numerator just have imaginary number. Nothing, no real number it has. So it is its real part. What is its real part? So it must be equal to 0. This we have to prove. So continue watch my videos and subscribe this channel and share it with your friends. If you like the